Bismillahirrahmanirrahim. Dear students, today we are going to discuss about the continuous time convolution method. Okay, the method which we are following is known as the range method for the continuous time convolution here. Okay, as we know that whenever we want to convolve, we need to convolve two signals here. So the question is convolve the following signals by convolution for range method. The one signal is x of t, the second signal is h of t here. Okay, now before starting the convolution, the first thing is, since we have to use the convolution integral, so we need to know what are the functions of x of t and h of t here. If the function for x of t or whatever signal given to you, or similarly h of t or whatever signal given to you, if the functions are given to you already, so it means we can directly start with the procedure here. But right now I have not given you the function for h of t and x of t. So let us first discuss that what are the functions for x and h signals here. Okay, so first of all, what is the function for x of t? So as you can see here, this is a linear, this is a signal which has a constant value here. Okay, so between 0 and 2, I have a function of x of t as constant 1 here. So obviously it will be 1 between these particular values here. Okay, first thing, so it's clear. The x of t is a constant value which is 1 here. Now if we see the signal h of t, we find that we don't have any constant signal here. Instead, we have a signal which is like some sort of slanting line here. So what we need to do here, so let's find the function of this signal by using the equation of line here. So we have multiple equation. One of the equation is y minus y1 divided by x minus x1 is equal to y1 minus y2 divided by x1 minus x2 here. So this is the equation of line here. You should have studied in your mathematics course here. So what we have here, along x-axis, my signal x is t here. Along y-axis, it is h of t here. So in the equation here, I will replace y and x with t and h of t. Okay. Now what we have, I have 2 points here. You can take 2 points, and I'm going to represent it in this form, x comma y here. Okay. So what is the value of x here? It's 0 and y here is 1. So it means this is x1, y1. Similarly, this is x equal to 2 and y here is 0. So you can see these are the 2 points here. Okay, 2 set of points here. Up to you. Okay, it's your choice. Either you can write here x1, y1 or you can write this one as x1, y1. Similarly, you can change here. Okay, so right now what I have done here, I have written x1 and y1 here, and I have written x2 and y2 here. So I'm going to substitute the values here. Everything is available to me. So what we have, y equal to h of t, as I told you earlier, minus, what is your y1? y1 is 1, so I put 1 here, divided by x is t, minus x1 is 0, is equal to y1 is 1 minus y2 is 0, 0, x1 is 0 minus 2. Okay, so just play around it, simplify it. Basically, we are going to get h of t equal to minus t by 2 plus 1 here. Okay, and you can verify here. Once you have this thing, you can simply verify it. What you will do, you can substitute the value at t equal to 0. When you put t0 here, you are going to get 1 here. So obviously, when value of t here is 0, I have the function h of t which is equal to 1. Similarly, if I put the value of t as 1 here, I'm going to get, when you put 1 here, so it will be like 1 minus half, which will be equal to half. Okay, so you can see at 1 here, maybe the value here is maybe half. Okay, so this will be half. Similarly, at 2, you can have like h of t equal to 2, which basically exactly the same point what I have in my signal h of t here. So basically the function for h of t is minus t by 2 plus 1. The function for x of t is 1. Okay, I did this step before the convolution because I'm going to use these functions when I'm going to solve the convolution integral in case of continuous time convolution. If the functions are already given to you, then okay, we can directly proceed. We don't have to do these steps here. Okay, so let's move forward here now. This is a convolution formula, convolution integral here. Again, as we discussed last time, they are commutative in property here. Okay, I can find x of t convolve with h of t, or I can do h of t convolve with x of t. So I'm going to get the same answer for both of them. So let's suppose my y of t here is my integration from minus infinity to infinity, x of tau. Okay, it's not t, it's a tau, another variable here, or another, yeah, and h of t minus tau into d of tau. So it means my convolution integral is integrating with respect to tau, not t. Similarly, if I say h and x here, so obviously instead of x I will have h, or instead of h I will have x here. So basically it's more or less the same concept what we discussed in the discrete time here. One signal will remain stationary, the other signal will be flipped. Okay, with respect to tau here, you can see I'm going to flip this signal, or with respect to tau, I'm going to flip x here. So up to you, you can decide which signal you want to keep constant, means without flipping, and which signal you want to flip here. Okay, so this is the formulas which we can use here. Now, first of all, what we are going to do from the given signal, we need to find the endpoints here. Okay, how we are going to find the endpoint? Simple. Let me go here. Let's suppose, okay, let me clear on the screen here. Okay. Now, first of all, what are the endpoints here? So obviously, my signal is starting from 0 and it is finishing at 2 here. So my endpoints here will be 0 and 2 here. Okay. Similarly, for this signal, my endpoints here is 0 and 2 here. Okay. Now, let's suppose I have some signal. Okay, I'm just giving. I have some signal which is, for example, something like this. Like this is 1, this is, for example, 2 here, and this is minus 1 here, and this is 1 here. Now, what are the endpoints of this signal here? So the endpoints of these signals are, you can see, it will be minus 1, comma, and 0. Why? Because I have the same function here between 0 and minus 1 here. Similarly, I have another function between 1 and 0 and 1, so it will be 1 here. So this is my endpoints here for this signal here. Okay, and then another example, let's suppose I have a signal and I say the signal is something like this. Maybe this is 2, this is minus 1 here, and this is 1 here, for example. What are the endpoints here? The endpoints here will be minus 1 and 2 here. Why minus 1 and 2? Why not minus 1, 0 and 2? Because I have the same constant signal here. So if my function is same, I'm going to count it as the endpoints here. Okay, so in this case the endpoint is 0 and 2. Similarly, it is 0 and 2 here. Okay, as clear from the signals here. This is the first thing. The second thing is, once we find the endpoint for the signal here, once we have the endpoints for x of t and h of t, which I have already shown, I need to find the pairwise sum here. Pairwise sum means I will take this value and I will add with this one, and then I will add with this one. Again, I will take the second value and I will add here and I will add here. So simple, 0 plus 0, 0 plus 2, then 2 plus 0 and 2 plus 2 here. So I will get this thing. Okay, the next step is, normally we need to rewrite them in the ascending form, means from smaller to bigger value. Okay, and we will remove the multiple values, means write it only one time here. So obviously 0 is here, 2 is repeated 2 times, so I will write 1 time, and 4 is repeated 1 time, so I will write 4. So basically these are the points for my convolution here, 0, 2 and 4 here. Is that clear, brothers? Okay, so simple. My points here is 0, 2 and 3, and what it is telling me, basically it is giving me the integration range here. So I need to integrate between 0 and 2 here first of all, then the second integration will be between 2 and 4 here. Okay, so basically I am integrating between 0 and 2 and 2 and 4 here. So 2 integrations will be here. So this was the first step in the convolution. The second step is we will use the formula here. Now what we have here, we have 2 signals here. What we have here, let me clear again. Okay, what we have 2 signals, x of t and h of t here. As per the formula, this is simple here. So I will try to keep this signal, I will try to keep this difficult or complex signal constant, means without flipping, and I'm going to flip this signal here. So basically I'm going to use this formula here. Okay, the second one here. Clear? But if you do the other way, it does not mean you will still get the same answer, but maybe sometime the convolution or the integration will become a bit complex here, but up to you. Okay. So I'm going to use this formula because I'm keeping h of tau constant and I'm going to flip this one. But again, first of all, I need to convert from h of t into h of tau and x of t into x of tau. Okay, because I'm doing basically the tau here. So it's simple here. Only if I want to convert here, I will convert my x's to tau here. So it means I change my variable to tau here. So it will be simply h of tau here. Similarly, x of t will become tau as my x-axis variable here, and it will become x of tau here. Next thing is I'm going to keep this one constant and I'm going to flip this signal here. So what I want here, basically I want to get x of t minus tau here. I want to get t minus tau here. So what I will do here, first of all, I need to flip here because it's minus tau here. So when you flip it, you will get minus tau as this one, means flip this one. So it will be between minus 2 and 0. Okay. Next step is I need to do t minus tau. So it's simple. It's with minus tau. I can have, like, for example, I can say minus tau plus t here. So whatever value I have here, I will say plus t here. So it means minus 2 plus t here, and this will be 0 plus t here. Okay. So minus 2 plus t and 0 plus t. Okay, so it means, let's suppose I have t some positive value. So t is this value and this will be t minus 2 here. Okay, simple. Now I have to signal h of tau and x of t minus tau, which are I'm going to use for my convolution here. Okay, so now first of all, as I have a formula here, so I need the signals here, or I need the functions x of t and t minus tau here. So what I have here, simple, x of t minus tau, simple, this is a constant value. I think this is 1 here. So it's constant between t minus 2 less than tau is less than equal to t here. Okay, from here. Similarly, we already calculated this function here, I think. Yeah, this is the function here. Only instead of t, I will replace t with tau here. So it will become h of tau equal to minus tau by 2 plus 1 here. So it's minus tau by 2 plus 1 between 0 and 2 here. So the tau value is 0 and 2 here. So from these two signals, were able to write x of t minus tau and h of tau here. Okay. Now, we will start the integration here. What we have, we need to start with the first range here. So my first range was between 0 and 2 here, as we discussed here. Okay, so let's suppose range is 0 is less than equal to t is less than equal to 2 here. Now for this particular range, okay, let me make this one here. What I'm having, this is the one signal given to me, like between, no, went back, let me. It is like, for example, say here, this is 2 roughly, this is 2, this is 1 here. Okay, this is a constant signal. The second signal means the x of tau. I need to take the signal and place it somewhere here. Now where I am going to place, importantly, remember that I need to place it somewhere so I can have the overlapping between the two signals, or means like the one signal can come above the other signal somehow. Because if they are overlapping, then only I can do the convolution and I can do the integration here. If they are not overlapping with each other, then obviously I cannot do the integration. It will give me 0 always. Okay. Now where to put the signal? Somewhere here. Simple. What we have here, I will take this one. This one. This is what we have. Okay. My range was 0 and 2. So my lower value here, I mean this value 0 and 2 here. So I will take the smaller value 0 and I will put it here in the first one, and I will take the other value and give me here. Okay, so this will become minus 2 and this will become 2 here. So it means I can put this signal any point between minus 2 and 2 here. Okay, any point in between. Okay, not on the point, it should be in between. This is one way of doing it. Okay, there are also other ways of understanding that where I can place it, but I'm using this method and I'm going to place it between -2 and 2, in between -2 and 2. So let's suppose I place it between, in between -2 and 2, somewhere here. Okay, now what we have here, I have one signal like this, the other signal is this one. Okay, and this is the area where they are overlapping with each other. Okay, of course this will, you cannot count it as the area here, but they are overlapping between 0 and t here. This is what I want to tell you. So only the overlapping is between 0 and t, so I am going to integrate between 0 and t. So the formula was y of t equal to, this was h of tau into x of t minus tau. So h of tau is this signal minus tau by 2 plus 1, and x of tau is 1. So just simply put the values here. This is h of tau into x of t minus tau. H of tau into x of t minus tau. So this is 1 here. Okay, so just do the integration here between 0 and t. So you are going to end up with this points here. Okay, integration is simple, straightforward integration here. So what we have to do here now, we got this value here. Now what we need to do here, we need to calculate the values of y of t at these 2 points here. So we need to put 0 here. When we substitute the value 0 here in the function, we will get 0. So my value output y is 0 at particular point 0 is 0. I will take this value and put it again in the function here. So when you put 2 here, you are going to get here 1. So basically I got 0 and 1 between the two functions here for this particular points here. Okay, so this was my first range here. Now I need to move to the next range, which is 0 and 2 here. So for 0 and 2 I need to do again the convolution integration here. So I will go here and I'm going to use the convolution integration here. So again the range here is 2 and 4 here. I put a constant signal here, but where I need to put the other signal, simple. I will take 2 and 4 and I will substitute it in this formula here. So when I put 2 here, so it will become 0 and this will become 4 here. So I can put it any point between 0 and 4 here. So between 0 and 4, I put it in between some point such that they are together overlapping with each other. So this is the point of overlapping here. This is t minus 2 and this is 2, and I'm going to integrate between t minus 2 and 2 here. Okay, so t minus 2 and 2, and I integrate between minus t by 2 plus 1 and d of t here. Okay, the same thing here. Obviously 1 is here for x of t, but 1 multiplied by anything is 1. Same thing. So that's why I have not written here. Just integrate it, somehow you will end up with this particular function here. Okay, so again, as what we did previously, we will find the value of y for 2 and for 4 here. So we put the value 2 and 4 here. We got 1 and 0 here. Okay, now at this point you need to check. This is y of 2 calculated using this particular function here. Same here. I have y of 2 calculated using a different function, which is this one here. Remember, like this is 2, it's the same point, so I'm going to get the same value even if you calculate using different functions here. Okay, so if you get two different values, for example, for the y of 2 I get 1 here, for example, I calculate here and I get maybe 2 here, for example. So this is not allowed. Okay, this is wrong basically, because for the same point I should have the same value also. So in that case, it means you can cross check your solution. There will be some problem or some mistake from your side. Okay, then you can correct it. So you should get the same value for these points here. Next thing is for 4 I got 0 here. Okay, so just I did nothing here, just I rewrite the functions here. Y of t was this function minus t square by 4 plus t between 0 to 2. Between 0 to 2. Similarly, y of t is this function between 2 to 4 here. Okay. So this is the function here. Now we already found our points here. We can now plot y of t here. Now, simple. At 0, it was 0 here. Okay, and at 2 it is 1. So at 0 it is 0. At 2 it is 1 here. Okay. Next thing is again using the same one. 2 and 4. It is 1 and 0 again. So at 4 it is 0 again here. So now the next point is how to join them. is it going to be a linear line here, or it is going to be some non-linear line here? So what you will do in this case, you need to look for the functions here, this function and this function. Obviously t square and t square are not a linear function, so obviously they are not the lines here. This will be some type of curve here, either it will go up or it will go down here. Okay, so how to check if it is going up or down here? Quickly, you can take one point in between for this one and you can put it in this function here, because this is the function for between 0 to 2. So for example, at 1, if I put 1 here, I got the value maybe 1 by 4, maybe no, 3 by 4. I got the value 3 by 4 here. Okay, so you can see here at 1, I have just plotted the 3 by 4 here, this point here. So obviously, you know the trend is going up, so I have a curve which is going up here. Similarly, for the second one, I just take another point, which is for example 3 here. I put it in this function and I got 1.4 here. So it means this is a point which is going down here. This is the point here. So you can see the trend is going down here. So you can make a sketch like this here. Means the curve which is going down here. So this is basically your y of t which we have plotted here. Okay. So this was all about the convolution. Just quickly revising, what are the steps here? We will have x of t, h of t. First step is, if we have the functions for this thing, we will find the endpoints of one signal and endpoint of the second signal. Second point is, we are going to find the pairwise sum here. And then we will arrange them in ascending order. Multiple values we will write one time, so it will give me my convolution range here. Okay, so here we got two range, which is 0 to 2 and 2 to 4 here. Next step was, we try to keep one signal without shifting or flipping, and we take the other simple signal, we flip it and we shift it here, so we got the signals here. So just we only write the functions here which we are going to use for the convolution here. Next step was, for each particular convolution range, we just find what are the area, what are the points which are overlapping with each other, and we found the convolution integral for it. Once we have the integration function, after the integration we got a function, we put the value for this range to find the points here. We did the same for the other range value, and finally we plotted it. Okay, and we check if it is a linear line or non-linear line. If it is linear, just simply draw a line here. If it is non-linear, try to find one more point. It will give you the trend, either it is going up or down. Okay, so this was all about the continuous time convolution. Thank you, brothers. Assalamu alaikum.